Up next, we are zooming from market landscape down to the trenches. Our next speaker is Volkan Ertürk, Picus co-founder and CTO. Volkan's session is titled Exposure Validation, Breakthrough, or Just Another Buzzword. Volkan, let's find out.
Thanks, Ron. I'm excited being here. Thanks to Eric, now we have a solid understanding of what exposure validation is and what it promises. But before we celebrate it, let's rewind a little bit. Because exposure validation didn't come up in a vacuum. It's not just a new trend, but it's a response. A response to a vulnerability management model that's broken. So if we really would like to understand why exposure validation matters, we need to understand what it is trying to fix. And this is where I want to start my presentation. So since the beginning of the year, looking at until the beginning of May, we see 16,000 new vulnerabilities emerge, like 133 vulnerabilities per day on average. And year-over-year growth rate is 30%. And the worst part is like 61% of those vulnerabilities labeled as high or critical, right? So like the attack surface is expanding, as we can see easily. And it is going faster than most teams can realistically patch. If you look at our patch cycles, it's like on average 60 days, and our critical patching speed is like 24 hours, only 10%, 11% of the organizations can actually meet that one up, right? So focusing on 61% of the high critical vulnerabilities doesn't cut it, doesn't make it happen. Also, we need to look into what Eric from CISA mentioned here. So in his conversation, he's saying that like with the speed of emerging vulnerabilities, patching faster is not sustainable. Definitely, he is talking about a couple of avenues. One of them is vendors has to be very careful with their software development life cycle. So we need to have less vulnerabilities for sure. But as an organizations, like we cannot expect and wait for our vendors to do better software development. So we need to address it on our end. And as we know, the patching is not the solution. We need to have another approach to this. So if you look into what's the real problem here, we see that like assessing vulnerabilities based on its technical nature causes tools to really flag these vulnerabilities as high. And this approach is overlooking the feasibility of an attack in your specific environment. And this really inflates the number of vulnerabilities we have here. So actually we are looking at vulnerabilities that are not realistically exploitable, and we are trying to patch them. We are trying to attack them all. So this really comes up with, like, you know your problem better than I do, for sure, because like most of the teams are living in this. But in order to summarize them, like we have resource misallocation, which is like the time and effort we put patching the low risk or irrelevant vulnerabilities takes our time to patch the truly dangerous ones. The remediation inefficiency comes with our patching effort becoming reactive and scattershot, often disrupting our operations. And the security IT team burnout is like we are always firefighting and trying to catch up what's going on there. And in terms of our reportings, like how secure we are, what's our posture, our risk assessments and reporting becomes inaccurate, and it turned out to be a loss of credibility in the organization side. So, like this is really a high level overview, but I want to really go through an example to better explain the over-prioritization problem. So let's take Log4j, a classical yet a critical one, right? So when the vulnerability was disclosed, in this organization, we did a vulnerability scan, and we identified that HR management system, intranet, and the credit application has Log4j. Perfect. Okay. So let's look at how we can prioritize and take actions on that. CVSS is 10.0, right? We all know that. Okay, it's critical, and we need to patch all. Perfect. Does it helpful? Yeah, I know, like every log4j I find out, I need to patch it. What else? Because I need some staging. I want to be focused on what I need to patch first, because in this example, we see 3, but maybe you have 50 or 100 or 500, right? So let's look at the exploitability. The vulnerability intelligence parameter is coming up as very high likely that the vulnerability will be exploited, right? In the next 30 days, let's say, with EPSS. So does it change anything in our end? No, because like we know that the moment log4j was disclosed, we know that the attackers already start abusing in the first minutes of that, because the exploitation was relatively easy to figure out and to iterate on that one. So with vulnerability intelligence, still we have everything critical we need to patch all. Let's look at asset criticality. Well, these are the assets that we have PII data or sensitive company information. So like all the assets criticality is high. So that takes us with most of the organizations are using these parameters. Everyone now looking into, okay, we have a log4j, any log4j we identified in our production environments. In this example, this 3, we need to patch urgently in the first maybe 24 hours. But we are also thinking about like this, right? So how about my security controls? I have several security controls and I have layered defense. I'm reducing my attack surface. So can it help me? And like in this diagram, it's like a basic architecture of the organization. We can see that my HR management system is living on a cloud provider due to my architectural decisions, limitations, or budget needs. It's just living with few security controls. However, my intranet, my credit application is on my data center. I have more controls. So intuitively, I feel like I know that actually my HR management system is a higher risk asset compared to other few. But like we need to treat them the same way, right? Because our algorithm says that everything is critical and you need to be rushed all of them at the same time starting now. So this is the tricky part. The current vulnerability scoring models we have is relying on the external factors. You can have this architecture, or you can have like open source, very limited security tools, or you double your budget and the engineers you have, or triple it. This doesn't change. It always gives you the same criticality score. That's the tricky part. That's not really working with our current vulnerability management model. And is it a new thing? Actually not. Like leveraging security controls is just already there. Like when in our conversations, we hear that forward thinking organizations saying like, we are discussing that, or we even pivoted that. That's my idea. I hear a couple of times on that one. And if you look at the CVSS technical specification, what we also hear is that like actually environmental metrics, which is also including the security controls, stated that like it is recommended to be considered for more accurate reflection of the severity score. So even the CVSS technical specification defined that one, and organizations are into that. Why we are not using our security controls for the criticality calculation of our vulnerabilities? But when I think about this and I talk to the security leaders and the security practitioners, what we hear is that, or what we observe is that there's tooling gaps, right? So the vulnerability scanners, the vulnerability tools that we use in our program doesn't really include breach attack simulation kind of control effectiveness, identification. And if organization even have those tools running in their environment, they're under different teams, and there's no a good way of integrating those tools to each other with native integrations I'm talking about. And when they try to do it by themselves, what we see is that manually trying to correlate them through spreadsheets or trying to write middlewares is creating a lot of operational complexity. So it just don't really make things move forward on their end. So join me discussing the exposure validation. So with this, exposure validation is the process of verifying whether an exposure is actually exploitable within your environment. So the exploitability is about your organization. It's not like a broad term concept. So in order to validate an exposure, you need to test those exposures in your environment, and then you can really identify and take them are like, this is exploitable and this is a theoretical one. And then all you need to do is deprioritize the theoretical ones and focus on what attackers can really exploit in your environment. So that's the real concept, how we look into better better prioritizing our vulnerabilities in our environment. And how does it look like? What it will going to change? So on the left-hand side, we have been discussing about exposures criticality, which is 10. And on the right-hand side, we are looking into, if you consider security control effectiveness into the picture, what it's going to change and how it will going to change. So we see that the scores will going to diminish. It's not 10, not 9.1, 7.3, 5.2. So it looks promising. Right now we have some staging. So it helps us to focus on my HR management system is critical. I want to focus on that one. My credit application becomes 5.2, which becomes a medium criticality. And I have an extended SLA for that one. Even maybe for high exposures, you have an extended SLA too. So you can buy time, not fetching them in the first few days, but maybe you have few weeks or even a month time to patch the highly protected assets. This is how we look into this from the blue teamers or the organization's point of view, right? But if you're looking at from the attacker's point of view, what does the attacker see? Do they see the left-hand side or the right-hand side? Actually, they also see the right-hand side. Because if we have security controls, it introduces additional frictions for them to pass the exploits to our organization. So actually trying to exploit the HRMS versus a credit app is not the same complexity, because we have several additional security controls, like they need to evade, they need to bypass, and maybe they need to slow down while in the course of their actions. So attacker's lens point of view is also works in this model too. So let's look into how to make this happen. Today, we are very excited to welcome exposure validation product to Picus. I'm very excited for that one. We have been working for more than 2 years to make this possible. And we appreciate your time joining us to celebrate and talking about the exposure validation of Picus. So as you know, 11 years ago, Picus started with breach attack simulation, or you're just not hearing that now. We are the pioneer, we are the leader in security control validation, running attack simulations to validate security controls. In time, we extend our portfolio to validate the cloud controls, infrastructure controls with automated pen testing, and making a deep analysis on the detection stacks. And we put all this layer and organization data overlaid on top of each other in our data fabric. And we build our platform modules and the products. And the exposure validation is the newest kid on the block. And we will be diving into that one in the session and in the coming sessions. So what does Picus exposure validation means and what does it do? Picus exposure validation automates the end-to-end exposure validation process for the organizations. And it helps it helps organizations to get an evidence-based exposure score. And what does it mean? It gives you a true list of exploitable exposures, which is 2% of all your exposures in your organization. Yeah, it is very dramatic, right? 2% of all your exposures or even your vulnerabilities you can think about. And like in the next session, Gürsel will be talking about how this works in the UI. And Süleyman will be talking about from our early availability customers, how their huge set of vulnerabilities being shortlisted to 2% of the exploitable ones. But before going into those sessions, I want to really walk you through how exposure validation works in Picus. First, we analyze, like for a given vulnerability, we analyze the vulnerability and asset context. We understand what we want to test and what we want to score around. And once we understand the vulnerability and asset, we guide organizations to run security control validation or breach attack simulation tests to validate their security controls. Following that, we calculate a score, which is called security control effectiveness, which is giving an understanding about how that exposure can be exploited and what is the effectiveness of the security controls protecting that device. Then we will be calculating the vulnerabilities exposure score. And if we are looking into how this score can further be adjusted with hardening security controls, so that's the final step, how we can remediate these findings. So now I will take you through the example of this journey. And we will look into how 10 becomes 9.5, 7.3, and 5.2. So I'm going to start with the intranet one. So for this one, we are lucky that we have a Picus simulation agent. So we know that for Log4j, what are the relevant threats are, and we simulate the relevant threats on the Picus agent against the security controls. It can be endpoint, network, and the detection stack. So running those simulations, Picus give us results, what is being blocked, what is being detected on the different levels of security controls. And at this point, we get a security control effectiveness result. So we get that 0.66, 0.53, and 0.61. Means that 66% of the threats being blocked by our network security control. And then the security control effectiveness score is matched by or composed by Log4j's dynamics, which is the vulnerability intelligence and the CVSS score, and we come up with an exposure score. And we will get into the details very soon on this one. But at this point, I'm hearing some of the audience saying like, hey, like, do you mean that we want to have simulation agents across every endpoint, every system, every asset in our network? No, we don't want to do that. I'm sure you don't want to do that too, right? So you don't want to create that much noise in your environment. It's not practical. It's not reasonable running continuous attack simulations in your production assets, endpoints, and the server systems. So at this point, I want to introduce you another technology that's core functionality of our exposure validation product, which is the extrapolation engine. So we developed a supervised machine learning model that predicts how security controls on a device will respond to a simulated attack. So how we do that? We leverage billions of historical simulation results and the security control configurations, because like Picus has been running this business for more than 11 years. So leveraging this big data, the model delivers accurate, scalable, and proactive insights about the security control effectiveness of the organization. I know that we all have privacy and security concerns with what's going on with Gen AI, but I'm happy to share that like we all run this process and all the training data is hosted on the Picus infrastructure, and no simulation is data or any data points has been shared with any third parties, including Gen AI tools. So, like this is how the extrapolation engine works. So for any point in the organization, Picus leveraged the big data we have over the years of time and the infrastructure from the other simulations in the organization and calculate the results. And the more agent-based simulations or more extended asset context information, feed it to the extrapolation engine of the customer environment, we will get defined security control effectiveness calculations. So in this example, for 5.2, we know that it is the credit application. So we have an estimated score, which is coming from network endpoint and detection stack calculations. And we compose them up with the CVSS and EPSS score. We come up with 5.2. That is how the beauty introduced our life with extrapolation engine. We don't need to have dedicated agents across the board to have a security score effectiveness calculation. So what does it changes in our life? So currently in our vulnerability management model, we can patch or we can harden the devices as a response to the vulnerability management as part of the vulnerability management program. But now it's introducing 2 additional options with the security controls. We can prevent or we can detect as a remediation action. So how does it help to our lives? Just imagine an emerging vulnerability. So another log4j emerges. Then like what, in order to not only patching, but also you can ask security teams, can we leverage our existing security controls to reduce the immediate risk? If the security teams can take this way, then the IT teams can have extended timeline to patch or harden the affected systems. So that's the beauty. It's really getting into our lives with the extended response actions. And so another point about the response part is just doubling down the previous example and what we discussed initially. So we get a refined score of 7.3. It's coming from 10, 7.3. Some of the organizations say, I'm happy because it's not critical, it's high now, or medium. But now we can say that I need further improvement in my score. Maybe I want to get into medium, so I need to buy time because of my change management life cycle. I cannot patch it in a week or a few days. Perfect. Then what security teams can do is that they can look into the Picus mitigation library. What are the compensating controls? How they can further improve their network security controls, endpoint security controls, or their detection stack, so that with the control effectiveness increase, they can reduce the exposure score. In this example, we click all the buttons, we improve the network, endpoint, and the detection stack effectiveness, and it gives us a reduction in the exposure score from 7.3 to 5.9. So we discussed how it works, but I want to highlight a couple of points about the exposure validation. What we see about the critical capabilities you need to be very careful about with the exposure validation is it should be evidence-based. So I will talk about what it means on the Picus side, and we can talk on the on more extended level. So we are born as a breach attack simulation player. So every threat in our library is evidence-based. Here is the payload, and the payloads are executed, and we always share, as you can see, the terminal output, the evidence, what is being blocked, not blocked, logged, alerted, not alerted. So if it is blocked, here is the result. If it's not blocked, here is the operation completed successfully prompt. Is it logged? Where are the logs? Is it alerted? Where are the alerts? So you can easily see evidence-based, and if an auditor or if another team comes over, why you are discounting that one, you always have things to share about this one. And the second and the third article is about transparency and traceable scoring. And I also tied the third one here. Here you can see that what is the exploitability probability? What is the security control effectiveness? What's the business criticality? You can see all the components. And as you see that when you go to the security control effectiveness, it's breakdown into what's your effectiveness on the network, endpoint, the detection side, and for the exploitability, which vulnerability intelligence feed you are using. Maybe you're using one or multiple. So what is the business criticality? How you pull that in and how you tie that into the weighting of your scoring. So everything is here. There's no black magic. It's nothing behind the curtains. Like if you cannot see, if you cannot trust that one, how you can explain it and how you can bet on that one. So that's how we look into this, because you're making a decision to deprioritize a vulnerability. If something happened, an incident happened through that deprioritized vulnerability, then it's actually vulnerability management team's reputation is there. So anything we want to do, we need to be sure that it is evidence-based, and we can always come up with data points to show that here is the decision we made. This is coming from this angle. So a vendor couldn't hack it, or it is mapped to this avenue. It doesn't work that way to our test. So today, I talk about the current vulnerability management challenges, which is like over-prioritization and ignoring the feasibility of an attack. And we introduced an exposure validation approach, which is the process of taking your exposures that are theoretical ones and the exploitable ones, and it provides you a pragmatic way of deprioritizing your theoretical vulnerabilities so that you can focus on the truly mattered ones for your organizations. And in this journey, Picus is helping organizations to end-to-end automate this process. We are the best-in-class security validation technology, and we provide fully automated evidence-based transparent exposure scoring. And we also help organizations to better improve their controls so that it can further help the vulnerability management process to migrate the exposures with compensating controls. So that's it on my side. Thank you very much for your time. Ron, over to you.
Thank you, Volkan. So we have time for one question. Let's go ahead and bring it up from the audience. This one says, how can we trust the deprioritization of Picus exposure validation? Other platforms also use some data to create scores. What makes Picus's approach different?
Yeah, that is like, it was just my talk track before the summary slide, but I guess the timing is there. But as we have a couple of more minutes, let me dig into that one. What is critical is like you can map your security control saying like, hey, I have an IPS rule. This is helping me for log4j. Or is it really what you can bet on? We don't believe that. That's the core value of breach attack simulation. Configuration is an assumption. So you cannot say that, hey, I have configuration items enabled, so I'm protected for log4j, so I can discount log4j. No, it doesn't work that way. Because like as I discussed here in this slide, that breach attack simulation in the last 10 years proved organizations and the industry that like configuration is an assumption. You need to be sure that your security controls are working as expected, running real attack simulations. So like that's a critical one. Don't assume the configuration mappings. Be sure that what you're assuming is to be validated with evidences. So you can trace down, and when an auditor comes into, you can say that, hey, here is the proof for that one. And the second part is important for us is, like, also we have a pen test automation product, and we see the pen test automation market is hype. But we cannot say that, hey, we run pen test automation, this vulnerability or this exposure wasn't able to be exploited, so let's take them as theoretical. Like, you cannot do that, right? So everyone, and we're going to ask you as a devil's advocate mode, saying like, hey, maybe that tool wasn't able to address that one. Or maybe from that segment, from that IP, there is a problem reaching to that segment. So a pen test automation doesn't tag that as exploitable, not necessarily means that it is an exploitable or a theoretical one. So what Picus's view is that for testing log4j, we have more than 35 different techniques in our database in this example. So you can run those 35 different payloads in your environment, and you can validate how each of your security controls responding into that one on your network security endpoint and then detection stack. So at the end, at the end to end, you can have an evidence-based how each one is doing for you. So we believe that this is the way, and we already been through this in our early build clients, talking to the leadership teams, talking to auditors and the other teams, and making it traceable, making it evidence-based really is moving the needle. So that's a great question. We can talk a lot. I'm sure like having a conversation around this one is more helpful, but I guess this helps to a little bit dig down into what we have been discussing about evidence-based exposure validation topic.